Hey, did you hear that Kenny G died in a horrible bus accident?
No.
What? No, I didn't hear that.
Yeah, he didn't. It's just one of those things that I wish happened.
And they say Duane is evil.
I know, right? Would they play his music at the funeral? I don't know. Maybe. Everybody go to sleep. Oh, wow.
Welcome to Security This Week. It's Carl Franklin. We have a special episode today. We've got a host, Jeremy Likness, and this is for a video that we're doing for DevExpress. So a little bit of a different format, but we're going to roll it as is. Hi, I'm Carl Franklin, and I'm here on behalf of DevExpress to talk to some security professionals about best practices in security for developers. And our esteemed guest is Jeremy Likness. Jeremy, tell everybody what you do at Microsoft.
Sure. I am the product manager for .NET backends. So that's minimal APIs, web APIs, MVC, all the technology in ASP.NET Core that drives the backend. Dan Roth is our front-end partner in that endeavor. Blazor, I think a few people know about that. So
you've heard of
he's
it.
on that side. And as part of that, I get to own the identity management story, which includes authentication and authorization.
It sounds like you're the perfect person to talk to about this topic. Also with me are the Security This Week regulars, Patrick Hines and Duane LaFlotte. Patrick, tell everybody what you do.
I basically just yell at Duane. Ask him to hack faster. Hack faster, Duane. So I'm the CEO of Pulsar Security, and basically we do white hat hacking.
Right. And so for those who don't know, you get hired to be evil.
We're always evil. We just get paid by customers.
Yes,
sometimes.
we help companies find the weaknesses by exploiting them and then giving them a lesson on what a hacker would do to their network if they were to get a hold of it.
Right. And Duane, you are one of the hackers, one of the white hat hackers that has extensive experience in getting in the box, as it's called.
Yeah, right. I know. So yeah, I'm the CTO at Pulsar Security, but also one of our head red teamers. So lead a team in thinking the dark thoughts and breaking into websites and figuring out how to steal all the juicy data. So that's what we get paid to do.
And how long have you guys, Pulsar Security, been doing what you do?
Late 90s. So a long time, over 20 years.
Mm-hmm.
Wow.
Back before cyber was a thing.
That's awesome, because I've been hacked since the late 90s, so it's like...
Coincidence?
It was Duane.
I apologize.
Or does he?
We never put a face on your data.
Yeah.
Far preferable to be hacked by the good people than the other way. So,
absolutely. Yeah. People have asked Duane, why don't you just go rogue, go evil? Because you could obviously make millions and millions of dollars.
I get that a lot.
He likes living in the United States.
Yeah. No, it's funny. You do get asked that a lot. And usually my response is the same reason I don't go and hit the side of your car with a crowbar and steal it and go sell it. I could do that too, but
right.
But that would be wrong.
Right.
Yes,
yeah, exactly.
Oh no, we're not doing the wink.
All right. So we're here to give developers incentive and information about best practices about security. Security is something that developers don't like. I know, because I'm a software developer, and I've never liked having to think about, being secure. I like to develop with no restrictions. Admin mode, everything just right there, access to everything. And then, when you start learning about some of these regular problems that happen, that's when, you kind of get incentivized to do things that you may not have been thinking of.
You don't have the same relationship with performance, though. Even though performance is similar.
Yeah.
Performance is very similar. Yeah, as a musician, it's different. Oh, not that kind of performance. I know what you mean.
Yeah. No, a little bit different.
Yeah, a little bit different. All right. So, guys, let's go down the list here of best practices. And I won't say top 10 things because I think we have more than 10 topics, but we certainly called a list of topics that every developer should be talking about. Let's start with HTML encoding. Who wants this? What is it and why is it important?
Let me start with HTML encoding. First off, for all of the developers out there, HTML encoding is not another algorithm of encryption. That's something I would like to put out there. There are a lot of times when we're pen testing an application, the first thing we do is look for how data is being bounced back and forth between the web application and the back end, or between clients and whatnot.
I got to have you define pen testing.
Oh, yeah, absolutely. So pen testing is where you have someone like us who's really good at understanding how all of these systems are connected, tear it apart and see if there are ways that we can get this system to do things that it was never designed to do.
Penetration testing is what
log in as different people, that sort of stuff. Penetration testing. Although, I get the weird looks when I say I'm a penetration tester.
Yeah. Okay. But it means hacking from the outside, trying to get inside.
Exactly. And what I find is like HTML encoding is interesting because you can take a string and you can put it in almost this HTML language that looks different. So a lot of people go, oh, it must be encrypted. Nobody can understand what this is. So my first sort of warning here is HTML encoding is a way of taking a string of all different types of characters and being able to safely pass it around on the internet. But be warned that it's not a security mechanism by any means.
Yeah.
Right.
But why is it important to do that for security reasons? And where? When?
That's a great question. Yeah. From a security standpoint, anytime you expect somebody's going to use characters, well, actually, anytime really, you should be encoding all the data so that it will pass successfully through the internet. But the problem is if you don't expect them to use certain characters, let's say I don't expect a user to put in a tick or a weird Chinese symbol or something along those lines.
Or a Cyrillic character, which
exactly
can look a lot like an ASCII character, but isn't.
So those are in the extended ASCII set.
Yeah.
So if you just try and transmit those, live from your web browser to the web backend, you start to run into issues, unexpected results. So anytime you can, you definitely want to encode it so that string is now safe. What happens is all of that string is going to get encoded into safe characters that can be sent over the wire, over the internet, and received by the server, and the server will decode them and then use them so that you don't see weird bugs you wouldn't be expecting.
Besides weird bugs, are there any vulnerabilities that can arise if you're not expecting or not using HTML encoding?
There are. Yeah, there's a number of them. One of the first things we'll do with an application, especially if we're starting to take a look at a web app, first thing is understand its functionality. What does it do? And what shouldn't it do? The next thing we do is what's called fuzzing. And fuzzing is where I'm going to take every character you didn't imagine I would throw at the web app, and I'm going to throw it at it. You're going to ask for my username, and I'm going to give it my username. And then I'm going to give it 10,000 characters, 10,000 A's, and I'm going to give it a bunch of dashes, and I'm going to give it a tick and a dash, and I'm going to give it a bunch of Cyrillic numbers or characters. So fuzzing is where I'm going to try every different combination of extended as well as basic ASCII characters to see if I can induce an error. And one of the most simplest things, one of the most simple reasons why I would do this is if I can get your application to throw an error, it gives me data I didn't have. The whole hacking process is grab information, understand what you know now, redesign your attack, grab more information, understand what you didn't know before, redesign your attacks. You're always going through this process of
rinse, repeat,
attack, and then research, and attack and research until you get to the back end. Right. So for me to understand would be a great thing to do.
Yeah. Jeremy, if a developer doesn't take precautions to hide unhandled exception details, what can happen?
Well, I mean, there's a few things I'm thinking of, and I'm not a pen tester, but I do appreciate what our pen testers do. I'm thinking of exception details, but I'm also thinking about leaked HTML code too. So I'll get to that in a second. But the exception details simply throw and provide information. Now, part of our job is to make it as easy for you to fall into good practices as possible, but you can't do a perfect job because it's a moving target. For example, let's say that you threw an exception and it was on a line of code that had a variable that had a password in it. Then suddenly you can expose that sensitive information. You can expose information about how your code is written that you don't want people to see because it's part of your intellectual property or part of a login secure routine, etc. So there's that aspect. The other aspect, though, that we take a lot of effort to make sure that, for example, when you read a string and you write that string out to your HTML output, that it's encoded. So when it's encoded, if you have HTML tags, it provides a display of HTML tags, but it doesn't interpret them as tags. So if I say script source equals my malicious script that's going to take over the internet, it'll just display that as opposed to actually embedding it into the browser and calling it, and then you're compromised for that. So those are the two areas I see as a concern there.
So that brings me to the question, should we never have inline script? Should we always have script in a JavaScript file that gets linked in?
Always is tough.
I can take this one. Yeah, always is tough. From an attacker's perspective, I love how modular and easy a lot of these frameworks are, because they do introduce a lot of these openings for me to then attack a website. Oh, can I inject code? Just like Jeremy was talking about, when we're doing cross-site scripting, for example, if you type in your username and then log in, and on the next page it says like, sorry, Duane, this wasn't the right username or whatever, but I can put code in there. And instead of displaying my name, it displays, a pop-up message or something along those lines. There are ways through cross-site scripting for me to steal either cookies or, different other types of objects that I want. So I would say it's tough.
I guess we should define cross-site scripting too.
It's on the list.
It is on the list. I don't want to go too deep into it.
That's okay.
We're jumping the stack.
I know, right? That's how all this hacking works. You just keep moving around.
Right.
So cross-site scripting is where I would have the ability to inject, at its simplest form, is me injecting code into the browser, into the response from the server that it didn't have already. So it's either me supplying JavaScript, or it would be me being able to manipulate the source of an image, and have it reference out to my hacker website and pull down a script that way. So there are multiple ways for me to cross-site pull script from a different site or supply it from myself. That's considered cross-site scripting.
Okay. All right. So that cross-site scripting. So I interrupted you mid-thought about
about HTML encoding.
About HTML encoding, yeah.
Yeah, and all I was saying is, you can't restrict developers to saying you can never do these types of things. You can never allow inline script other than, say a source from a JavaScript, because frankly, we could find ways around that.
Sure.
So really, you just need to make sure that you're putting whatever best practices you can. Anytime you get user supplied data, whether that's a username, a password, or, data that's going to be injected into a data table or something along those lines, you need to make sure it's not malicious. And if you're going to display it back to the users, you need to make sure it's in a benign way by using something like HTML encoding.
These are all variations on a theme. So the original place that we saw this was SQL injection. And basically parameterizing queries is encoding them so that you're not getting something unexpected. And if we really want to boil it down, encoding is about looking for what you expect instead of taking what you get.
Yeah.
So you need a way to make sure that if let's say I had a personal assistant, I don't want to say the name because I don't want everybody across the country's A word to light up and start ordering.
Oh, you're no fun.
Things. I'm no fun. But if you had one of those and you said, I want you to, like, if you hear the word buy, I want you to ignore the rest of it because I don't want to buy anything. But it understands German, so kaufen, that works. If you try to stop the bad stuff, you typically fail. Because there's so much bad stuff in so many ways.
Yeah.
So you want to look for the good stuff. And encoding gives us a way to look for the things that we're looking for. That's an oversimplification, perhaps, but that's the way to think of it.
Well, I like that you brought up that comparison to SQL, because I think of another concept that I've learned in the database world, which is least privilege, right? And we'll talk about it later, so I'm not going to get into it, but there are ways of securing your application so that you can assume that, no, you're not going to allow any inline code. But then you hit that scenario where you need it, you can open it up a little bit, but you can protect that little piece that you have and assume that there's not going to be anything else. And you layer on top, and it's a really crummy way to have to code, right? You're so restrictive and you're slowly coming out of the box, but it's a lot better than being wide open and saying, hey, everyone.
You should treat your code like kids you like. You should only let them do the things they should be able to do, not anything they want to do.
Right.
All right, let's talk about secrets. And by secrets, I mean passwords and keys and things that we don't want anybody who's using our software or anybody who has access to it to see. Best practices. I mean, is something like Key Vault absolutely necessary for any web application? Or if I simply keep it out of my GitHub repo and put my configuration in Azure configuration or whatever, what do I do there?
There's levels. So you just highlighted a couple of levels. First is don't publish it to the internet. That's a good way to start. Don't put it on your website. That's good. But then there's levels above that, and Key Vaults and those systems are the best level because they're designed for this use case.
Yeah. And sometimes it could be something simple. It used to be, hey, if I had a config file, maybe I'll just put the SQL Server username and password in that config file, right? Mm-hmm. Who's going to get access to the config file? And then we started seeing what are called LFIs, which are local file includes. And local file includes aren't necessarily dangerous, but they can view data sitting on the local hard drive of the web server. And if I tell it to read the config file, it'll tell me it, right? And then I can see a username and password.
What is that exactly? Is it just like it sounds? Is what's on the tin? A local file include means pull in this file and read it like a config file?
Yeah. What's weird about a local file include is you go, okay, so Duane, that's what web servers do, right? They take local files and they display them up. But what if I were to, we all know that the web.config, for example, in IIS is restricted. .config files cannot be displayed. There's no parser or processor in IIS to display that file.
Yeah.
So you wouldn't see it. You would call it and it'd give you a 404 and it wouldn't allow that to happen. Mm-hmm. But what if I had an ASPX page that allowed me to, maybe put in a language file, and instead of the language file, say, give me the web.config, and it reads it and spits it out on the page for me. So now I have what's called a local file include. I can actually read files off the drive, potentially in any location, and see it.
So the web server engine's not serving it up. The ASP process is reading the file, and it then serves it up in a way that isn't caught by the config prohibition.
Doesn't the programmer have to make that stupid mistake? I mean, you'd have to be pretty thick to willfully read a config file. How does that happen?
No, not at all.
It's more about they're trying to read something else, like your profile.
Yeah, let's say, for example, I'm running a restaurant. And in my restaurant, we say, listen, we're not going to use databases or any of that sort of stuff for our menus. That would be silly. We're just going to record customer orders in the database. Okay. And I have a menus directory. And in that menus directory, I have a bunch of text files that, servers can update and say what the new menu items are for the day. And then when you go to our menu for the day, we just say, okay, load up the file that is in /menu/today.txt, and it loads it up. Well, if in your URL bar it says menu ? Today equals today.txt. Well, I can change that today.txt to anything I want. So I could say .. /web.config, and it will then read it like it thinks it's reading the menu.
And the developer doesn't realize that you can go up directories.
Correct.
And doesn't think about what presence they have. What's the account that's making that request, and what does it have access to? Because they're used to everything admin all the time.
Well, and then take the arms race, right? Oh, well, I'll just look for ... I won't allow them to go up a directory. Well, %C0%AF is also ... So most people wouldn't potentially be looking for those things. So that's why it's good to not keep secrets on the drive, just so we can sort of all sort of come to that same place. But there are simple things you could do. Like I know a lot of people will use what I'll do is I'll actually have a system variable that stores a secret.
You mean an environment variable?
Yeah, exactly. So it's either an environment, a system variable. I store it up there. I store whatever the secret is. My website has access to it, but there's nothing to read. There's no way to pull that secret off. So that's a minimal layer of security. But you're right, Patrick. It's in layers. Where do you want to keep it, and how secure are you trying to keep those?
And one of the things to point out too is these layers are available to developers too. So there's the local measures that you can take, moving it into the environment or moving it and using the secrets mechanism in ASP.NET Web Apps so that the secrets are stored in a safe place. And then something like Key Vault is powerful not just because of the way it stores secrets, but the way it allows you to manage them. So now you have to change something. Are you going everywhere and changing it, or do you have a centralized place that you can change it without applying a code update? And I think it's important for people to think along those lines, like, what's convenient for me as a local developer, and then what makes sense as this starts to scale and there's more people involved. And the nice thing, I hope, and, developers can tell me if I'm wrong, but our configuration system allows fallback. So you can check here and look there. So you can design your application in such a way that you have the convenience of your environment variables set up on your local system, but you're using Key Vault to do the production deployment and manage the secrets when they're out in the wild, so to speak.
So, Jeremy, I have a question. If you're using an app service in Azure, one of the, obviously a safer option than putting your secrets in app settings.json, let's say, is adding them to the Azure general configuration application. What do they call them? Properties, I think they are. Just like
sure.
Application, there's like a, key value pairs that you can put in there for config, and it'll read them out of there. What's the difference between that and putting them in full-blown key vault?
I think, it comes down to key rotation and updating and management of the keys at scale. So there you still have to have a way to go into that script and set the individual properties, where key vault is a centralized location. So I can have a connection string for a database. I can reference it multiple places, but when I have to rotate the key because it's compromised, I do it in one place because everything's pointing to it, as opposed to going out to 50 applications and changing it in 50 web app configuration settings. So
okay, so it isn't really the whether it's more or less secure, it's that it's easier to manage.
Well, I mean, if you look at least privilege too, if I can put it into Key Vault and not make it available to you and you can't see it even in the Azure portal, I would argue that is a layer of security as well.
Yeah, and I'll tell you, most of the time, Carl, when we break into a website, a customer site or whatever it is, a lot of times it's a configuration issue. Right. So it's I forgot that file was there. Or I forgot that we had a backup directory that was holding the web.config in there. I forgot that we had et cetera, et cetera, et cetera. So I know Patrick's, catch line is always, convenience is the enemy of security. But I think there's a caveat to that. This is convenient, although the setup's a little bit more complicated than just putting the keys in. But what's nice about this convenience is it makes it so that if you have a sprawling web, farm of application with lots of different keys, it makes it so you don't forget one. Right. So although it's more convenient, you have more control over what's out there. So there are certain times that convenience actually can be quite a bit more secure like this.
Got it. What if you have a desktop or mobile client where you don't have the luxury of putting your keys on the internet somewhere in a key vault? Maybe you do. How do we protect secrets like database connection strings for desktop applications, mobile applications?
So I can start. I can definitely tell you, most people, or at least developers, when they're deploying to a mobile application, assume that most of the data that is there is completely secure. Like, I don't need to worry about it. I can just put a connection file in there and I can read it. Unfortunately, there are plenty of ways to tear apart mobile applications, plenty of ways, obviously, to tear apart thick applications sitting on a desktop. So this is where typically I'll recommend some of the obviously encryption makes sense. Should never have any of this data in clear text. If you can make a call out to a remote service, this is also another way to be able to pull down these connection strings in a more secure manner. But if you don't have that available to you, even something simple like DPAPI, the thing I would warn you against is don't try and roll your own fancy encryption algorithm. Honestly, trust me. Like, I'm wearing the Bletchley shirt today. There are a lot smarter people out there in cryptography than you. No offense. There are a lot smarter people out there than me. And rolling your own cryptography is never a good option.
Yeah. Jeremy, what do you think? Desktop or mobile apps? Can we use Key Vault for that?
Key Vault is an option, right? If you're using the .NET stack for that, I'm pretty sure. Let's say I haven't built one myself, but for the client though, in general on those apps, I think about anything I'm going to store on the mobile app or the desktop app is anything that I'm perfectly comfortable with that user of that app browsing through, looking at, and owning. So I want to protect their data from anyone else seeing it, but I also want to protect my data from them seeing it. To that extent, anytime I can put data behind a service that only provides it when they're authenticated, so I know they are who they say they are,
right,
then I'm going to go with that route. If I don't have that luxury, then to Duane's, like, for example, if I'm in that boat, I'm probably not in the boat to use Key Vault either, right? For some reason, right, I'm not able to connect to a managed service. And so in that case, I would absolutely encrypt and ensure that however I stored it, I assume that the user can just browse easily and read it. And what they're going to see is something that they're not going to be able to use that connection.
Again, I guess we're talking about, old legacy apps that they aren't modernized, like a modernized Windows Forms WPF app or even mobile app would simply allow the user to log in and then use an authenticated API. Mm-hmm. The API would then have access to the database, and that's behind the firewall. So they wouldn't even have a connection string on the client.
Right. You've kind of poked the hornet's nest because you're talking about a military application. In many regards, there's a military app that is disconnected, doesn't count on internet, is encrypted at rest. And so encryption at rest so that you can't reboot the system and get it from an alternate partition where you're an administrator. This is hardening. This is where the STIG process that the military uses, that's why it's such a pain, is because, it's security, technical.
Oh, it's an acronym.
Something. Yeah, it's an old acronym. I haven't spelled that one out in a number of years, but basically, in order for a computer to be on a military network, it has to follow a certain level of STIG, and they shut things off wholesale. So they turn off whole subsystems. And so you're really coming to a problem where if you can have a service authenticate you, it's much better than having to, there's a high cost to being on offline only, either in security or in inconvenience.
So, but if we have an app that's, an intranet application, let's say it's written in, VB6 and we're still running it for some reason, or
there's your problem.
Windows Forms, and it talks to a local database. Do we even care about encrypting those connection strings?
Yeah, we do. At 100%. Yeah. And here's why I say this. I, within the last month, have actually done a red team engagement against a customer that did have a VB6 app that did connect to a database. And it was really easy for us to then take the connection to the database, parlay that into us controlling the database server because they weren't implementing these privileges. And then at that point, move around and take over the entire network. So, yeah, you want to be careful because we're looking for the weakest point in a network. And if that weakest point is your VB6 app using not encryption because you go, whatever, we're going to get rid of it at some point anyways, realize that for me is a great day to find one of those.
It's kind of like you're asking, how can I get 9-year-olds on horses to beat tanks? Not a good question to ask.
Right. Yeah, right. All right, guys, let's talk about how to limit access to different websites that may have authentication in there. Definitely have authentication, but let's talk about content security policy and CORS.
Fun.
First of all, what's content security policy?
Yeah, so content security policy, to distill it down, is a way for you to say what content can load on your website and from where, which is the important part. I've seen a lot of people go, when I configure this for dev, it works. But when it goes into production, things break. So then the thing they do is they put that little star in there. They say, load any content from anywhere. And then it works again. And you go, oh my God, yay, it works. But what that does is it opens it up to me, who has evilhacker.com. And if I'm able to inject scripts into your website, as everybody goes to that website.
Yeah, I know.
I'm able to inject scripts into your website. And because you don't have a content security policy that says, please don't load things from other cross domains, et cetera, that sort of stuff. So from a simple standpoint, that's what content security policies do, is restrict where content can come from and what content can run on your site.
So content can come from like it results of an API, that kind of thing, or iframes, or what?
Anything.
Yeah, anything. Yeah, you can configure it for, hey, I only want to allow this API on the back end, these Azure APIs and my website. And that's it.
It's like firewall. It's not really a firewall, but it's kind of like that. It's what are the rules of the road? What is in bounds for the web server?
All right. And by the way, we're going to have links in the show notes for all of these things. So we're not getting into the technical details of it, but these are just things that you should be paying attention to. Jeremy, you have something to say about that?
Just on the content security policy, what I love about it is you can also specify that you do not allow inline code. So, for example, if I have JavaScript, I have to reference it by a file as opposed to a script block. If I do want a script block, I can tag that script block. There's fancy terms like nonces and hashes and things that we don't necessarily have to get into, but that have a signature of the code. So if it's tampered with, it will fail to load.
Yep.
And even turning it on for a site like my personal website, I turned it on and made it most restrictive. It can be very revealing what third-party libraries you might be relying on and what privacy concerns they may be raising. You just might be surprised at what domains it goes out to because it stops working because X domain is blocked and you're like, I'm not referencing anything from X domain.
Right.
Well, it's because you have this plugin that references that plugin that. So it's a really eye-opening experience.
It's like using a black light in a hotel room.
Patrick, you always have the best analogies.
That is horrifying. Thank you, Patrick.
Definitely. Where are you staying, Duane? You're in a hotel right now.
Why would you need a black light? Oh, okay.
Yeah, thank you. Thank you.
Okay, so CORS. What is CORS? Cross-origin resource sharing? What is that? Why do we need it anyway? I thought everything was open, right? Why do we need CORS?
Well, when we talked about cross-site scripting and SQL injection have been at the top of the OWASP top 10 for as long as there's been an OWASP top 10.
And that's the top 10, vulnerabilities or whatever.
Gotchas, the
gotchas,
the boogeymen of web development. If I don't have a CORS policy or if I have an asterisk for the CORS policy, I'm basically saying that content from other places can be intertwined. Sometimes that's what you want, but you don't want it unrestricted because somebody can manipulate so that a page gets included. As Duane was saying, if he finds a way for him to include his script, it has to come from a different domain unless he's managed to get it onto your server. It's a real big shortcut in the hacking route if I can get you to serve something up that I have somewhere else instead of me having to get it on your server for it to be served up.
Okay.
So it's a big obstacle. So the CORS policy is set up for that specific reason. You can say nothing's allowed, which is your best bet. Or if you have a specific need, you can say, well, this specific domain is allowed because I trust it to provide me content. But you got to be aware of the asterisk because the asterisk even in front of a domain. So for example, let's say I have, franklins.com, one of Carl's websites. If I trust franklins.com, that sounds like it's secure. But if I go register hackfranklins.com, the asterisk saves me. And so I need to be specific in my CORS policy.
You mean hack without a period, hackfranklins.com.
Yeah, because the asterisk is...
But if it was *franklins.net or whatever,
then I'd have to get a subdomain registered, which isn't impossible, but it's a lot higher.
Okay.
Certainly much harder.
So a lot of developers that write APIs, API layers or whatever, that's running in a different domain or a different thing. And so they often find that, cross-origin resource, the CORS policy isn't allowing this. So what do? They put an asterisk, allow everybody, right?
And that's lazy.
Yeah. So what they should do is then specify that we only are taking requests from whatever the client domain is, right? Asterisks.
Maybe even move how it's configured into configuration so it can be changed by environment. But the whole thing, like this comes up with authentication all the time because if someone's using a third party authentication provider, they need to open the site to be able to pass information between the two. And, especially if you want a white label experience, right? So you want it to look like you're staying on your site. So opening that star opens up just a whole can of worms that these gentlemen are very familiar with.
One of the things that we find is that people are lazier in protecting their clients than they are in protecting their own assets. And that means that cross-site scripting and CORS policy is typically the last thing on the list, if there's even a list, because it's the client, it's the browser, it's the person on the other end that's going to get hacked. Their server's not going to get ransomwared. Right. Most of the times, it's the client's workstation and their servers that are going to get ransomware.
Yeah.
So if you care about your clients and client service, why don't you do them the courtesy of actually protecting them and follow a CORS policy, follow the origin policy.
All right. I want to blow through some of these other topics here because we have about 20 minutes left. Public-facing site considerations. So if you have, if you're not making a site just for your customers or whatever, but you're making a Twitter.com or a Tutor.com or whatever, you have a public-facing site that. Are there any special security considerations that you need to take into account for those kinds of sites?
There's a million of them, probably.
Yeah, there are. I would say every website is a public-facing website, right? I mean, every website, even internal websites or public-facing websites, there are ways for me to load an internal-only website from the internet. We've exploited sites where we've had one web server then make a call to a local port that's only accessible locally to then use a configuration website. So you got to assume every website, no matter what it is a public-facing website. Somebody may be able to get access to it that you don't want there. That being said, every website should have the, security reviews that you would do on a public website. Never trust any of the input any of the users or applications send you. Realize that the only way to talk to your website is not through a browser. There are many ways to proxy data to websites and manipulate that data in the middle. So if you're doing weird things like, I'm just logging in the database all of the web browser headers that come from the web browser as to what type of browser it is, whether it's Firefox, whether it's Mozilla, whether it's whatever, realize a hacker could actually inject SQL injection right into that header. And you might not be thinking about it. So that would be my biggest tip for public-facing websites is never trust what you're getting from the browser or the user. Any of that data could be manipulated.
So what do we do if we're, how do we protect ourselves against that? Is it all the things that we've already been talking about? The HTML encoding,
Yes, it's all of these things and more, because the problem is that, as we said in the beginning, security is a tax upon development. People see it as it's a feature that nobody wants to pay for.
Right.
But if you don't have it, it's certainly a feature nobody wants to pay for because the server's going to be down, the system's going to be taken over. Your reputation's on the line.
And the fact is, you could lose a lot more money than what you'd spend on security development.
Reputation and all that stuff. So you have to add it to the process. If you built a house and then you decided after it was built to make it secure, it would cost a lot more than to build the house securely.
Right.
And so a magic list, this is a really good list, but there's no magic list. You have to build things securely. And that's all the things we're talking about.
Yeah.
So, I absolutely agree with you, Patrick. And there's a lot of things that you can layer into the security of a public-facing website. We can talk about web application firewalls. We can talk about parameterized queries, if you're using SQL Server or data tables. We can talk about microservices in the back end that are authenticated. We can talk about single sign-on. So there's all sorts of things you look at there. But one of the things I like to talk about here is all of these services in their own way are kind of their own isolated security island, right? Think of it this way. I have an API on the back end that gets me access to data. It has authentication around it and whatnot. I have my website that might be presenting my front end. I have a web application firewall that's washing the traffic that's coming from the users. The other thing I typically recommend is to stand on the back of giants, if you will. So use controls from companies that actually go through a process to vet the security of those controls. Far too often we see things like WordPress get hacked into because we wanted to use this really cool controller plugin. And then we realize, nobody's actually looking at it for security. They don't actually do code reviews. They don't, it's just thrown out there so people can use it. And I trusted it. So you need to cultivate that list of vendors where you know their controls are solid. You know that their APIs are solid, and then sort of stick to those and use those.
That gets us solidly into dependency mapping and checking and SBOM, software bills of materials. But Jeremy, it looks like you had a comment.
Oh, I was just going to say it's another area where it's important to change your approach and your thought, how you develop the application, because it's so easy to say Blazor server lets me build a client experience, but I have all the connectivity of the server. I can connect right to the database. Mm-hmm. If that user has access, do you really want them to have access to the database? And I would far prefer to only give them access to the website.
Yeah.
And then the website has access to the database.
Right.
And add those layers like bulkheads, like in a submarine, right?
Least privilege.
Yep.
You just described least privilege, which we talked about earlier.
Exactly. So think about ways that you restrict to the minimum possible that gets the user's job done, and then delegate the rest farther downstream where it's a lot safer.
All right. Let's talk SBOMs. Patrick, I know this is you guys are hot on SBOMs. I know Microsoft is too. Software bill of materials. What is it? Why do we need it?
So software bill of materials is the idea that when you build software, you need to provide to your client a list of all the technologies, tools, add-ons, services, everything that could be affected. Because what we learned is the Log4j last year when it came out, everybody was looking around to say, well, does this application that I'm using use Log4j? It's a component. It's kind of like finding out that green peanut butter peanuts are poisonous and you don't know what they're in. Right? Because they could be used in sauces and things like that.
Right.
So by having that list of ingredients for a software package, we now can say, oh, well, I have a database with all my SBOMs of all the software I use. Log4j has just had another vulnerability. Let me go look. Oh, I have 5 applications that have it. Let me go see if they have fixes. Instead of what ended up happening is we had to try to hack every application to see if it was vulnerable. Because half the time the company, you'd call them up and say, we have no idea whether you're using Log4j. The developers who worked on this module aren't here anymore, and we're using code from this vendor over here. And so it's the idea that without an inventory, you really can't know if you're secure. As Duane probably could point out, if he's got a feed going right now, in the 45 minutes or so we've been talking, there's probably been dozens of exploits that have come out. And so in order to keep track of them, we have to know ahead of time. And so software bill of materials is a concept that's coming to a theater near you. Expect that everybody needs to know about it. Their tools are starting to emerge.
Yeah, I was going to ask Jeremy, does Microsoft have any tools to map dependencies? Like if I say I take a dependency on this NuGet package, which is at this GitHub, whatever, can it then, make a tree for me of dependencies? Are there tools that Microsoft has for that?
I assume there are. I'm definitely not the expert on those tools, but I can tell you that that's part of what GitHub does, right? It has dependency bot that looks at your dependencies and does that. So that technology is available. I know with NuGet, there's been a lot of announcements about basically securing the packages and having stronger, signature and other technology to ensure that. But that is definitely not my area.
Okay. I think they do have these tools. And I remember talking to somebody on .NET Rocks about this not too long ago. But yeah, you want to look into that. And we'll provide links where we can in the show notes. But if you have something that you could, give your list of NuGet packages or could read your project files or whatever, and then it could generate a list of dependencies. And here's the thing, updates. You got to keep updating. You have to always use the latest versions of things. That's just so important. It's important for you, for your operating system, right? Keep Windows updated, right? It's important for your software routers and your Wi-Fi routers. If you're not using something that automatically updates the firmware, then you have to check it and you have to go look on a regular basis to see if there's new patches available. Yeah. Patch. And it's the same for your tools. You absolutely have to keep things updated.
Yeah. Right. Yeah, there's an ugly word for when you go too long without patching regularly. It's called migrating. And it's much preferable to patch and stay current than to suddenly be stuck with a migration because you're so far behind, right?
I love that.
Right.
Yeah. All right. So Patrick, you and Duane, your company does penetration testing and you're not cheap.
Thanks.
No, you're not. You're not.
No, we are not.
No, you're not. This is not news.
You don't slouch yourself, Carl.
Yeah, I know, right? Yeah, you're not even cheap when we go out to dinner. All right. Well, anyway, how does a company can a company do penetration testing themselves? And why would they do that to save money? I mean,
there's 3 levels. Yeah. You can do at home dentistry too. I wouldn't recommend it. So there's 3 levels. So there's vulnerability assessments.
Yeah.
Which is automated tools will do that. We do that. That basically goes and looks to see if there's anything, and this is using machine checking and things like that.
So you need a machine that's outside of your company looking from the outside to...
Well, you buy a software license. Usually the licenses are fairly expensive. So usually you're better off having somebody like us to do it. But vulnerability assessment is the first line of defense. So you can run your own. If you want to, and you'll get a list of potential vulnerabilities, then you have to run them down to see if they're real. To see if there really is a vulnerability there. Because it'll give you lots of false positives. That's the problem with that. But that's the base level. That you can do yourself. If you buy the software, you buy a good tester. There's lots of testers out there.
And you have to do it. You have to do it.
But, that's minimum. That's table stakes. But the problem is you can't flush out your assumptions. you can't check your own work. You can edit your own book or paper, but you're not going to find the assumptions that are the mistakes.
Right. You're not as evil as Duane.
Yeah.
No, I'm not nearly as evil as Duane.
Well, not you. I mean, you, the listener. I mean, the listener who's thinking, how am I going to do this? You have to be evil. You have to think.
Yeah, you have to think. It's a different mindset.
Yeah.
So, but the other thing is, it's even if you have the right mindset to have people with this skill, they're going to make the same assumptions. And we don't have those assumptions. So pen testing is when you tell us, hey, I want you to test these 5 systems, and we'll come in and test those 5 systems, which is great. And it's important. The problem with pen testing is you're not an expert on what we're going to use to get in your network. It's better for you to do a red team.
Right.
That's the highest level.
And a red team is? We
come in and we hack you like Russia or China, and we pick what we go after. With limitations, of course, because you'll get a more reasonable. It's kind of like me saying, I want you to try to break into my house through the bulkhead.
Yeah.
Well, what if I wouldn't use the bulkhead as a real criminal?
Right. Yeah.
What if the door's open? Right.
That's right. Well, you got a glass door on the patio. You got a screen door. So those are the different levels. I've recommended to some companies that were under a crunch, find another company in your space and have them, but they don't trust each other. That's the problem.
Right.
They don't want each other in each other's systems.
Yeah.
So honestly, if you're going to build an application, what we do is a lot of the times is somebody will build a web application, either a very large corporation or a software house, and they'll want us to do an application pen test.
Yeah.
And what we'll do is we'll look at that app and we'll attack it and we'll see. And we've had customers basically throw out complete apps because they've done the test. The vendor didn't. And we found things that were just unacceptable.
Yeah.
And one of them was related to cores. We do web applications, and there was a shopping cart application, and we were able to take over the shopping cart because they had an asterisk in front of the portal, the e-commerce portal.
Right.
The security policies, of course, yeah.
And so pen testing doesn't just apply to servers; it applies to applications as well.
Sure. Okay. And with what we have left, Jeremy, can you talk a little bit about how you guys are redesigning authentication and authorization for .NET 8?
Absolutely. So, authentication and authorization have been a top of the list priority for a lot of developers, the top voted list in the ASP.NET repo for specific scenarios. So when we talk about ways that you can authenticate and authorize your app, there are things that you can install locally. There are managed services. There are products. So there's a variety of ways. And so the scenario that we focused on for .NET 8 is what we call self-host. So this is where someone is hosting a site. They need login security, but they don't necessarily need to do things like call a web API with special security that's in a third-party system or grant access to an external system. These things require more complicated flows, but if it's just my users, my system, we call that self-host, and that's what the ASP.NET Core Identity System services. It gives you a self-host way of managing identities. And so what we focused on was a couple things. The single-page app experience, so when you're doing like Angular, JavaScript, or Blazor WebAssembly, for example, that experience was not the greatest experience because the screens that let you manage your identity experience, change your password, set up two-factor authentication, were all server rendered. So you went out of your, this is my snappy single-page application to here's an old-style server rendered experience and bounce back and forth. So to address that, we are exposing a set of APIs that people were hacking together themselves, but now we're giving them out of the box so that you can call an endpoint and do things like log in. And we're giving you the safest default option for when you're self-hosting, which is a cookie, because it's ambient, so to speak, right? So that cookie, once it's set, is automatically set in the header of the browser. You don't have to do anything as a developer. But the reality is there are clients, like some people will have this application stood up and they want a mobile client to access it. And a mobile client, if it's not running a browser, doesn't have a cookie management solution, right? So then we go to tokens. So we're providing tokens, but the important thing for people to understand is this is the easy, I'm setting up an app. It's a local app. We're trying to make that experience as easy as possible. If you get to the level that you need to start interfacing with multiple systems, etc., then you want to look at something like Azure AD, right, which is our offering for that, or something that we had before that was installed on premise called Identity Server, which is a OAuth OIDC. It's a set of technology related to authentication and authorization, but it gives you management of more complex flows with that. So we're not trying to be a security provider and provide that full-blown solution, but we do recognize we have a huge number of developers who have those isolated apps that just want to experience that they can feel secure without having the overhead of configuring like a full-blown OIDC server, etc.
I gotta say, Microsoft, when you guys get into the mode of solving the 80% use case, it's so good for developers, because we saw that with Web Services 1.0. It just made so many developers superheroes with just ease of access. But when you wanted to get into the nitty gritty of WSDL and stuff like that, you could. And so I think this is a great strategy of solve the problem for 80% of the systems and then have a place for them to go when it gets more complicated.
Thanks for that feedback. And the other piece of this is a lot of developers are using Azure AD, and that team understands that I don't think you'll talk to too many people and say, that was the easiest thing I ever did was set up Azure AD. We recognize that, and I'm working with that team to identify ways that we can improve that process, but that's not in the .NET 8 timeframe, unfortunately. So we have to prioritize.
Good to hear. We should also mention static code analysis. What do we think of that? That's something that's been around for a long time. It's not a panacea, but it's an important way to catch things. It's kind of like the vulnerability assessments that I talked about.
Yeah. So I like that. So for the listeners who aren't deep into static and dynamic code analysis, let me just talk about the topic a little bit. Static code analysis is if I take your code and I run it through some sort of engine, and we look for common mistakes, right? So we look for, you're using SQL and concatenating strings. That's a bad thing. You should never do that. You should use parameterized queries, blah, blah, blah. Static code analysis would pick those things up.
For example, like if it was written by me, it would catch that.
It would say 90% of the code's bad. And
way to put your reputation out there, Patrick.
I code, but I'm not a coder anymore.
That's what Patrick does when he goes to hack a site. He goes, what would I do?
If I want to get them to write good code, I wrote a prototype and said, let's use this. They're like, no, we'll write it. Don't worry. You stay away.
So static code analysis it is a good sort of entry level, understand what proper coding practices should have been used in an application. I mean, in the ideal world, listen, every one of your developers would be trained in proper code security development and you wouldn't have to worry about it, right? But that doesn't happen. And then the next step is, okay, static code analysis will actually tell me, no, you shouldn't do this. You shouldn't do that. This was a bad thing to, call this particular API in this way. These are things that shouldn't be done. So that's static code analysis. And I think it's a useful thing. I think the problem is a lot of people think of static code analysis as like, oh, well, it came back with the green check mark. We're good, right? There's nothing that anybody could ever do to this. And there's a gap between when the code is sitting there innate and inert on paper and not doing anything, and then when it's running. Dynamic code analysis is the application is actually up and in a live fire exercise, and we're the ones throwing, artillery rounds at it. And we're going to come at it at ways that are not normal, right? So that's where, okay, I'd say 80% of the time static code analysis is fantastic to get the initial, low hanging fruit. But if you really want to make sure that people aren't going to break in unique ways, then you have to move over to something like dynamic analysis, whether that's an internal department that does it or whether it's an external team.
And I just wanted to throw in that sometimes people think their code is pretty static and streamlined, but it's not really. For example, a lot of people use Entity Framework, and Entity Framework dynamically generates code to optimize querying. And if you don't know that, then you don't realize that you have attack vectors that don't show up in static code analysis because you're not generating that code until you're running the application.
That's an excellent point.
Moral of the story, use Dapper. So anyway, no, I'm kidding. Kidding, not kidding. Right. What else? Network layout, database versus front end. Does that matter?
It does. I actually really love Jeremy's analogy here of a submarine. we far too often we see hey, we have this database on the back end and the web servers can query the database. But you know what? Anybody on the internet can too. Just in case our developers need to come in from the office and one of them might be working from home. So and we're like, you have 1433 open to the internet? And they're like, yeah, it's fine because we have usernames and passwords. And it's like, it's fine. That's what it does.
6-character passwords, 6 whole characters.
Unguessable.
My cat name 123.
So, I think the architecture absolutely needs to be like, if I were to design an architecture for security in the physical world, I would use Patrick. He was West Point graduate, tank commander in the war. He knows how to defend a position, right? And he defends it in multiple layers of security. Same thing here. You want to make sure that your databases, your sort of crown jewels, whether it's data, access to application data, user data, whatever it is, it's as hard as possible to get through to that data in alternate paths. You have to come through the one line, the kill zone, if you will, of you have to log in, you have to be authenticated, you have to come in through the application, there have to be checks, and then you get access to it. So I think the network architecture and the application architecture have to work well together to make sure your data is as secure as possible. And that's all I got.
Well, guys, thank you very much for doing this with me. It means a lot to the developers in the trenches out there who don't think about security all the time. And there's so much information out there. It's hard to know what to do. But here you go from the horse's mouth. Thank you again for being with us.
Thanks for having us.
Yeah, thanks. And Jeremy, thank you for being on here. This has been fantastic to get an expert like you to jump in and chat.
Great talking to you.
Yes, thank you very much for that. It was great to come on, and you call me an expert, but the great thing about where I work is I work with experts. So I have security people that I lean on. We'll put it that way.
I can relate.
Very good. Okay, thanks. We'll see you next time. Maybe we'll do this again. Bye-bye.
Bye, guys.
Bye.